Thanks everyone for joining my SauceCon session on continuous performance testing in DevOps. I want to give you a quick introduction before we dive in. My name is Lee Barnes. I'm CTO of UTOPIA Solutions, and I've spent most of my 25+ year career focusing on performance testing and test automation, and most recently helping organizations implement those activities in their DevOps pipelines. I want to start with a controversial statement, and that's that performance testing is dead. And now that I hopefully have your attention, at least for those that fancy ourselves as performance test engineers, let me qualify that statement and add that traditional performance testing is dead, at least in DevOps environments. And to understand why I would make this controversial statement, let's take a look at what traditional performance testing generally looks like. Traditional performance testing was born out of the waterfall model, where a single cycle, of course, might stretch over months, sometimes years. And then after functional testing was completed, we developed and executed a large-scale system-level performance test, and that typically lasted many weeks. I spent a good portion of my career helping organizations set up these testing centers of excellence that became very effective at executing this type of performance tests and enforcing the often very strict rules that went along with it. For instance, your app must be functionally complete, because if you can't prove it works, at least with a single user, how in the world can I test it under a multi-user load? And for the entire time that we're doing our work, you need to freeze the code, because if something changes, I might have to start all over. And finally, if you want your results to mean anything, you better give me a production-like environment. So let's say we do that, maybe even if we're developing in more modern, iterative way, and we decide that we're going to have a hardening sprint, and part of that is this system-level performance test. If we find out we have performance issues after we've completed the development of the system, or maybe even just a feature, our options aren't that good. We either delay the release, and that means that we're delaying delivering the value to our customers, or we release and we get hit by the freight train. And that freight train has lost revenue, lost brand value, lost customer loyalty. And it's also the increased cost of remediation compared to if those issues were found much earlier on in the development cycle. But either way, our options are not good. The problem really worsens if I try to perform this traditional type performance test at the end of each development cycle. And at first glance, this might seem like the logical approach, right? The thought being that if I start relatively small and maintain that performance test as I go through my sprints, maybe I can keep up. But the reality is that there's just no way we can follow those traditional rules of performance testing if you're taking an agile approach to development. If we wait until new features are functionally complete and tested, there's just not time to enhance and maintain that performance test suite. Certainly can't freeze the code for a sprint or worse, multiple sprints while we develop and execute that performance test. And it's unlikely that we're going to have anything near a production type environment. So we end up combining these short agile development sprints with lengthy, rigid performance tests, and we end up with disaster. What it appears we are searching for here is a continuous feedback on performance, or something we can achieve through continuous performance testing. If that's what we're looking for, what is it? And maybe it's better to start with what I found that it's not. It's not just more frequent performance tests. It's not just moving performance testing to earlier in the cycle. And it's certainly not just faster or completely automated performance tests. But it is an appropriate level of evaluation of performance at each stage of the delivery cycle. It's more frequent, more visible feedback on performance. And an important aspect, as we'll find out, is trending those results across builds so we can build essentially a continuum of performance data as we develop our application. Okay, traditional performance testing doesn't work in agile DevOps cycles, but there are a lot of organizations that are building software via a DevOps approach. So let's take a look at what they're doing with respect to performance testing. Even if we look at elite DevOps performers, only 28% have automated performance tests. And if we read between the lines a little bit, given that most performance tests are in fact automated, we could infer that maybe only 28% of those organizations are performance testing at all. there must be something standing in the way. And in my experience, there's several things. So let's take a look at some of the more common obstacles that we can find with respect to building performance testing and analysis into our pipelines. First, the lack of performance requirements in user stories. If we're not thinking about performance from the beginning, it's difficult and probably unfair to expect the team to think about performance as features begin to move through the delivery cycle. Very similarly, development teams often lack the knowledge and experience for performance analysis and testing. And this is especially true in organizations where this function was handled by a separate team. And going hand in hand with that is the development teams not having the accountability for performance testing and analysis, especially in situations, again, where traditional performance testing was handled by a separate dedicated team. And finally, the concept of performance analysis was limited to running large-scale system-level performance tests very often, and the organization as a whole just didn't possess the skills or tools required to analyze performance at a much lower level. One of the huge holes in most organizations is the failure to think about performance testing from the beginning. This has created in older software development organizations where understanding the performance of the system was always someone else's responsibility. Like we just discussed, where the system's turned over to the performance test team at the end of a long waterfall cycle. The problem, of course, as we just talked about, is we surface performance issues way too late to do anything about it. I think another big concern is that it makes organizations lazy when it comes to performance. Again, it was always someone else's problem, so no one is thinking about that at the right time or at the right level. I think a great way to address this early, though, is to document performance factors as the stories are being created. So as you're creating your stories, think about performance factors that are important. For example, let's think about performance factors related to this story that describes the ability of a dealer to create quotes in the field for farm equipment. So maybe I know that we have a peak of about 1,200 concurrent users creating quotes. And given that we're literally going to be out in the field, we need to consider varying network conditions. And we don't want to deal with anything worse than 2-second screen-to-screen response time. Now, at this point, I don't recommend spending too much time on this. We're just trying to get these performance factors out in the open for the entire team to see, rather than leaving it for a performance engineer much later on. So thinking about those factors is a good first step, but at some point we're going to have to incorporate performance requirements more formally in our work. And I've seen a handful of approaches, and I think what's right really depends a bit on how the organization prefers to work. So let's look at some examples. One of the more popular approaches is to include performance requirements as constraints that certain or most or maybe even all stories need to meet. If you think about performance requirements, things like response times, support for a number of concurrent users, or some throughput volume, they often apply to many user stories. So as we create these stories, we can link their acceptance criteria as appropriate to existing constraints. Performance requirements that are specific to a story, it might make sense to include those requirements directly in the acceptance criteria. But we need to be mindful that user-level performance criteria will be very difficult to prove in a non-production-like environment. Another common thing that's missing for us to incorporate performance testing and analysis in the pipelines is accountability, as we just talked about. And it's not surprising that we have an issue with accountability for performance testing. There's still a lot of inertia around that old traditional performance testing where it was always someone else's responsibility. I think awareness is an important prerequisite to accountability. If our teams aren't aware of what we're trying to accomplish and why, we really can't hold them accountable. And I think two important ways to build awareness are to discuss those performance factors that we just talked about, and then incorporate those performance-related requirements into our work. Awareness is one thing, but if we're not constantly reminded of how important performance is, we're likely going to let it slip into the background. And I found the best way to make performance requirements visible is to ensure that our definition of done includes that these performance factors and requirements are documented. I've also seen organizations create the role of performance owner, and one even called it a performance czar. But it's important to note that responsibility of this role was not to own all things performance, but rather ensure that the teams were adopting a culture of performance accountability. They were more responsible for clearing the way for performance by providing guidance and ensuring that the teams had everything they needed from a performance perspective. Accountability is one thing, but we really can't expect teams to magically have all the skills and tools to implement performance-related processes into the delivery cycles. We need to build that expertise. And I would suggest starting small, and we'll talk more about the approach in a minute. But if you're part of an organization that has had a performance testing center of excellence or still does, you can bring those experts into the teams and start to seed them with expertise. And once the initial team becomes self-sustainable, you can begin to scale that across the organization. I think in parallel, it's a good idea to develop a virtual center of excellence that can provide the guidance and oversight for performance-related activities. And I'm not talking about a heavy process or oversight, but really just a virtual community that can work together to share ideas and lessons learned to ensure continued improvement and growth. You also need to be thinking about the appropriate tooling in upstream environments, right? Not just load generation tools, which may already be there, but also performance monitoring, diagnostic solutions that can help us understand more than just user level metrics. And all this is going to start to help you move performance testing analysis from a centralized, separate team to become more integrated in the way you develop and test software. What can we learn about performance in our pipelines? And I think a good way to start thinking about that is to look at the pipelines and consider where across the various stages we can learn about performance. So I've laid out a relatively simple pipeline here. And certainly we can learn about performance at the performance load stage, right? This is likely where we're going to execute something that looks more like a traditional system level performance test. But as we'll discuss, we're likely not going to execute this on every build. We certainly can learn about performance at the integration stage. And this is going to be focused likely on individual components, smaller groups of components, tests that can be executed quickly, have few dependencies, or have their dependencies mocked, but give us fast feedback. We'll also discuss what we can learn about performance in production. And finally, we might be able to learn something about performance when the code's committed, depending on what we're doing. But the key is to evolve to a state of regularly evaluating performance. It becomes much easier to track performance regressions to the commit where they were introduced. Let's start at the beginning of the pipeline and see what we can learn about performance at the commit stage. And really what I'm talking about here is unit performance testing. And yes, some organizations are practicing this. There are even some tools and libraries that are purpose-built for performance testing. The table here that I have on the screen is something that I gleaned from a somewhat recent research paper out of Charles University in Prague that lists the most popular performance unit test frameworks. But as this paper points out, popular is a really relative term here. I think they analyzed about 100,000 Java-based projects in GitHub and found only that about 3% of them had some form of performance unit testing. Most of them, about 72%, used the JMH framework, which is part of the OpenJDK project. Not every method in every class is going to warrant performance testing, but there's definitely benefit to testing performance at the unit level where appropriate. And these should be true unit tests where you've mocked the dependencies. You're just running them with multiple threads or multiple iterations as appropriate. We should note that running them as part of the build process can be problematic because you don't want other things going on in the build environment to impact those results. But frameworks like JMH can help you package up your tests and execute them in a more isolated environment so you can have more confidence in your results. Some important considerations for performance testing at this level, certainly. And probably the two most important are controlling the length of the tests and how the results are presented. First test would have to be run way too long to get a high confidence in the data for very small performance fluctuations. Therefore, we need to understand that these are going to detect only obvious changes in performance, which should be fine for most applications. Second, the absolute value of the results is much less important at this stage of the game than trending them from build to build. Reporting individual results back to developers isn't going to give them a whole lot of data, but if they can see build over build how performance is being impacted by their commits, that's much more valuable information. I wouldn't necessarily have your performance unit test break the build. Certainly not at first when you're just trying to implement this practice and understand what's what's appropriate from a results perspective. Moving down the pipeline, we can definitely learn about performance at the integration stage. And this is after we've checked in code, unit tests have passed, and we've deployed our new build into the integration environment. So what does that look like? Test focused on individual components, and these should be your most critical components, at least at first when we're just starting to implement this practice. We can always scale that once we've gained some experience and worked out the kinks. We're still early in the pipeline and we want fast feedback. So tests that include typically individual calls with a small number of concurrent threads and a small number of iterations. We're not executing real life load at this point. We want to limit the complexity of our test setup. So we're going to want to mock out any dependencies that the component might have. And we should also think about measuring more than just response times, but also some system level metrics by extending our APM tooling further up the delivery cycle. And of course, there's some important things to consider. We want to execute these tests on every build that gets deployed here if possible. But similar to unit performance testing, the results aren't necessarily deterministic, and we probably shouldn't have tests break the build. And again, we're not looking for absolute results here, right? As we just discussed, we're not putting real life load on the system. And of course, the environment isn't anything like production. So again, we want to look for trends across the builds. We're not trying to answer the questions about how the system is going to perform, how it's going to look from the user perspective in production. Rather, we're trying to get feedback about the performance of a component. Just so if we see something that we don't like, we can get that in the right person's hands to deal with it. The picture that I'm painting here is a relatively mature implementation. I would recommend that you not go back and try to recreate this immediately in your environment, not because it's necessarily difficult, but more because you want to build this in a way that is sustainable by your organization and provides value specific to your organization. Most groups start with a single component, maybe even triggering that manually just to get a feel for the type of data that's being generated and how they can take action on it. And we'll talk more about that in a little bit. Before I move down the pipeline, though, I do want to talk a little bit about testing performance at the unit and component level. Because let's not kid ourselves. Thinking about the applications and dividing them into nice, neat components and units is easier said than done. For microservice architectures, right, it's more intuitive, right? Certainly at the component level to do this. Each component is likely relatively focused in its scope and identifying its dependencies for the purpose of understanding mocking and service virtualization requirements should be relatively straightforward. They lend themselves very nicely to short, focused tests that can be run efficiently upstream. However, right, for monolithic architectures that many of us, I'm sure, still deal with, the idea of a component can be a bit fuzzy, and therefore the ability to execute very nice, neat little tests that focus on a specific component becomes considerably more difficult. So while you may not be able to accomplish the same level of compartmentalization, there's still some things we can do. A good place to start is to map user actions to specific areas of interest within the application. This might be a specific process in the application or business logic layer. So rather than thinking about testing from the user perspective, think about the areas of that monolith that have performance issues, or based on your knowledge of the system is a good candidate for performance testing, and then map user actions that can exercise those areas. We should end up with test scripts that only include the minimum number of steps to address those specific actions and avoid those traditional end-to-end user flows that we might see in traditional performance tests. Certainly for monoliths, the scope of performance testing you can do early in the delivery cycle may be limited. The tests tend to be a bit longer, have more dependencies, therefore the time to maintain them is going to be greater, and the ability to mock dependencies might be limited and require more setup time. All right, so let's move down to the acceptance stage. It's common to have an inline environment where additional component tests can be run, or small subsystems of components, as well as an out-of-line environment, again, where that more traditional system-level performance testing can be performed. For the inline environment, this is likely where you're going to be running your automated acceptance and regression tests as well. So I recommend, if possible, capturing end-user level performance metrics as part of those automated regression tests. And this can be added to most functional test automation frameworks relatively easily. where we can capture response times, user and browser level performance metrics, even HAR files if we use something like browser mob proxy. This data can be saved off as part of your execution results and then even sucked into a time series database if necessary for analysis. Ideally, you're going to be executing the component level tests on every deployment with the dependencies mocked. And then for the out-of-line system performance tests, you're going to execute these less frequently depending on where you are in your release cycle and other events that might warrant this type of testing. The key is that you're evaluating performance throughout the delivery cycle. And you can be much more selective about when you execute these larger and, of course, more expensive system level tests. I should say for these system level performance tests, all the recommended practices still apply, right? There's no magic just because we're part of a DevOps pipeline. You need to make sure that your load profile, the number of users, what they're doing, the throughput volumes, et cetera, is appropriate. You need to understand the data requirements for that test, and you've prepared them. You're prepared to monitor not only the user level metrics, but the system and infrastructure level metrics as well. I have seen rarely organizations execute this level of testing more frequently or even part of an automated deployment. It's, like I said, it's rare. Environment provisioning, configuration, and data setup need to be part of that automated process to make that happen. And the hardest part is making sure the tests themselves are ready for execution and haven't been impacted by application changes. So before we talk about testing in production, I want to give you a conceptual overview of the process and some representative technologies that can be used to put this together. As you'll see, I've listed some tools here, but they're just examples. They're not necessarily recommendations. So let's start with whatever we're testing. We're going to need some tool to generate the load and throughput. And then we'll want more than user level metrics, which is what we typically get out of a load test tool. So ideally, we're going to be monitoring the application and infrastructure while those tests are executing. Next, we want to collect the results. Then we're going to need some mechanism to alert the appropriate people that the tests have completed and maybe any anomalies that were detected. And of course, we'll want to make those results available to anyone that needs to see them. And finally, this process should be as automated as possible. You might be thinking this seems like a lot of work, and I don't see how I can carve off the time with everything else in my backlog. And you're right, this is not a trivial amount of work, but we don't need to build it overnight. And I think a good place to start, as I suggested earlier, execute a few simple component tests automatically as part of your build deployment. Then maybe get an APM solution running if there isn't one already, and then adding in a results selection and of course, moving on to broadcasting those results. And speaking of the backlog, this work should be part of it, part of that technical backlog, so it becomes part of your continuous improvement efforts. If this is off the books work, it's likely never going to be done. So you need to manage it in the same way you manage your normal development work. Again, I recommend starting small. A good place is running some component level tests against a few of your more critical components. Get comfortable with that process and the tools it takes. Work out the kinks and then scale to other components and other teams and eventually other stages of the delivery cycle. And as I mentioned, this should not be off the books work. Make it part of your technical backlog so it gets worked in and prioritized along with the rest of your development efforts. Part of getting comfortable with this is not overwhelming your team, right? Another good reason to start small, by the way. This is going to be information the team has likely not seen before. You need to prepare them so they're ready to consume it, but also act on it, right? And just as importantly, the team needs to have the skills and the understanding, right? It's unfair to assume that they possess the ability to understand the data that we're giving them in the first place, right? So this is going to be a learning process. And this is not just going to be implementing tools. We need to take care of some supporting factors. We don't have unlimited time to execute tests, right? We need fast feedback. So we need to think very critically about what tests we're including. And if these tests are going to be part of your delivery cycle, they're likely going to have to be run on demand. So what do we need to set up from a test environment and a data perspective to make that happen? And finally, this is not going to be a fire and forget solution, right? As we implement continuous performance testing, we should continuously get feedback from the team and improve the solution so it's adding the appropriate value. Its ability to understand performance data and take action on it evolves, that team's going to provide valuable feedback to you on what information they get and how they get it. I think most of us are probably monitoring our applications in production, or at least we should be. However, testing in production, which was once taboo, is fairly common today and an important part of a continuous performance strategy. From a testing perspective, the obvious benefit is the confirmation that production can support the expected load conditions, but also it allows us to test the entire system, right? Not just what's behind the firewall. And with the wide availability of cloud-based tools, we can evaluate user experience from various locations and various network conditions that more closely map to our real user and load profile. And we can combine testing with monitoring to give us feedback on specific data that we want by executing synthetic transactions in production. And we should create a continuous feedback loop between upstream testing and monitoring in production to improve both the test design and the monitoring configuration. There's some things that we need to maximize the benefits and, of course, minimize the risks. One mistake I see, especially from the performance testing side, is creating that strategy in a vacuum. You need to get input from across the organization so you can put together a comprehensive plan that adds value. If your app's hosted in a third-party environment, you need to coordinate the load tests with them, right? If you don't, you risk them making them, at a minimum, really unhappy, or more likely getting throttled or blocked during execution. Of course, if your app is already live, you have customers. So we need to find an execution window that minimizes the impact on those customers, or cordon off a part of the test environment for them while you run the test on the main part of your production environment. Next, and very important, is the system should know that it's being tested, right? After all, we're in production and we can really screw things up depending on what we're doing. So whether it's using custom headers, seeding test data in production, or some other means, you need the system to understand that it's dealing with synthetic transactions. And this is another reason to have broad IT input. If the system is architected from the beginning, or at least adapted over time to be tested in production, this all becomes a lot easier. Finally, it's a good idea to eliminate or mock requests to third-party services, right? We don't want to unintentionally impact their customers as part of our load test. I want to talk a little bit about testing and monitoring and the differences between them, as well as how observability fits in. I've seen a lot of opinions, well, maybe not a lot, but a few anyway, that argue that sufficient testing reduces or even eliminates the need for monitoring. And on the flip side, I've seen some people argue that sufficient monitoring eliminates the need for testing. And I think both of them are pretty ridiculous. I think rather testing, monitoring, and observability complements each other by giving answers to three distinct types of questions. Testing confirms the answers to questions that we already know the answer to, and we're just, again, confirming them. While monitoring gives us the ability to answer questions that we don't yet know the answer to. We know the question, but we're not sure what the answer is. And finally, observability goes a step further and gives us the ability to answer questions that we didn't know we'd have to ask in the first place. And certainly we could have a whole talk on observability, but I think it's an up-and-coming aspect to performance testing and analysis. Let's wrap up with some key takeaways. Traditional end-of-cycle performance tests just don't jive well with Agile DevOps delivery cycles. You can try, but it's typically going to end up in disaster. Continuous performance testing analysis is not just more faster for performance tests. We talked about some techniques and how we can evaluate performance at each stage in the pipeline. So again, it's not taking what we've always done in the past and just trying to do it more often or do it more quickly. Again, we can very proactively learn about performance at every stage of the pipeline, and we can understand if we have performance regressions much earlier and much closer to the commit that caused them. As we talked about the approach, right? Start small, get feedback, continuously improve. This isn't one of those projects where someone goes off in a corner in a vacuum, builds this phenomenal solution, and then implements it, and we expect everyone to be happy. It's going to be a learning process. This is data that a lot of people probably have not seen before, and it needs to be an evolution for sure. All right. Well, thank you again for joining my session. If you have any further questions, please feel free to reach out to me at any of these means here. And again, thank you for joining the session and for attending SauceCon. Thank you.